Canonical would like to take a little bit of a different approach to showing the distribution of Charmed OSM today. I think it's pretty important to highlight a number of things that you will face in a commercial distribution when deployed at scale for customers. So we've taken the liberty of showing a number of different demos that will highlight key features within the distribution as we see it today, all the problems that we see today. So Canonical is a founding member of OSM, as most of our esteemed colleagues over there. We are very proud to support the commercial version of OSM, and we've waited quite some time for this milestone, so I think the community in itself should be really proud of what's been achieved over the last few years in terms of feature sets and the abilities added to OSM to support actual true generic virtual network function management and NVOs. We have chosen specifically to use Kubernetes to deploy our OSM distribution on. We see everything moving towards microservices. We don't see any current need to just support VM-based deployments. Everything's in Docker containers anyway. And we've chosen specifically to allow for both the private cloud deployment of a distribution and to use any of the public clouds that supports a conformant Kubernetes like EKS, GKE or AKS. And obviously supporting the developer community, as you've seen this morning with the dev stack. So for us, it's extremely important, obviously, to focus on the developer community. We grow the community of OSM by enabling OSM community to actually go and develop, to actually play with OSM, to actually develop network services and to deploy their workloads into environments. So for us, it's very important that anyone should be able to pick up his laptop and be able to develop something and deploy it into a Vim, like you've seen this morning. For us, high availability was obviously a no-brainer. We added it in the same way we do everything else in our network infrastructure side of the house in Canonical when we talk about OpenStack or Kubernetes. We obviously require scalability. In production environments, it's essential that these components be able to scale and meet demand when those individual components need to react. And this is by default built into Juju as part of the lifecycle management aspect of that complex piece of software, in this case OSM. We remain true to upstream. We do not change upstream. We do feel that it is important in distribution to actually be able to react in real time to customer demands when it comes to things like bug fixes or security. So what Canonical does is we pull from upstream the source, and we build our own Docker containers after we CVE patch and bug fix those containers, and then make them available on a secured proxy, so Docker repository, towards distribution users, right? It's fully supported by Canonical. We have both engineering teams, sales organizations, field engineering teams that focus on specifically OSM. We've made a conscious choice to go all in. We feel that it's important that with our history in open source environments, that we also support this as to the full extent of what Canonical can do. And then obviously security, like I highlighted before, it's extremely important to ensure that the security aspects are taken care of. Now, the way we approached this was obviously Charmed OSM. Charmed OSM for us is a no-brainer. So we've obviously modeled OSM to be deployed using Juju into any environment, whether it be private cloud or public cloud. And the aspects that we feel are important is obviously not to make you figure out how to make this complex piece of software work, but to use it for its function, right? So if we remove that friction part of getting to a completely deployed OSM environment, you will then be able to innovate. We use the same standard process of charming complex pieces of software like we do for Kubernetes, like we do for OpenStack, and then like we do for the logging, monitoring, and alerting stack. And then I'll hand over to Eduardo, who will show you one of the key features of the distribution at scale for commercial use?
So one of the big problems that we face is that we need to interconnect different applications. In this case, it would be our Kubernetes cluster, OSM, with a logging and monitoring and alerting stack. So Juju supports different models. So we can deploy these stacks into different models and then integrate them together. So for that, we could create all of these models. So in this case, we would have two Charmed Kubernetes and a logging and monitoring and alerting stack. And we would create these relations. So these relations would entail that Nagios would be able to collect information from the agents that are running on the machines. Filebit will be able to push logs into the logging part of the LMA stack, and Prometheus will be able to get also that information. So I'm going to show. So I already have a deployed scenario on AWS, which is running two Charmed Kubernetes clusters, where OSM is running on top of them, and an LMA stack. So, and this is our LMA stack, where we have all of those components that I've talked before, and all the connections here below to the different components.
So to add some context there, if you deploy multiple clusters of OSM on Kubernetes or another substrate, in our case Kubernetes, you will want the capability to feed all the LMA data from those different clusters into a centralized LMA cluster so that you could centrally manage that from a single pane of glass. And the model relations is what we're showing here, the capability of deploying these at scale and then making sure that you still have that capability to manage the logging, monitoring, alerting from one central place.
So just to confirm that we, in fact, have it running. So here is our search. So I'll show Nagios instead. So here we have Nagios, for example. Let me just make it a bit bigger. Where you can see all the nodes for our CDK clusters and their state, and when the last check was performed. So this is running on a different time zone, so it's a bit different, the time there, but we are seeing. And you can also see Graylog, where you can go into, for example, let me check, so we can go into Mongo and see its logs here, for example, and we could check all the logs for all the models that are integrated with the LMS stack, including the OSM logs. So this is a good tool to debug OSM as well.
Sorry. So the other advantage of using Charmed OSM is that we can already include it inside of our internal tools that we already have for Canonical to deploy both OpenStack, Kubernetes, and several other Juju models onto clouds. So with this internal tool that I'm going to show off in the video, we can deploy from bare metals, OpenStack, Kubernetes, OSM, everything just with one command. So in this small video that I'm going to show now, we're basically going to deploy fully charmed Kubernetes, HA, 2 workers, 1 master, and OSM on an already existing OpenStack. This could also be achieved directly from bare metal using maps, OpenStack, Kubernetes, OSM, all deployed with just one command. Okay, now. Okay, so let me show it. So basically to simplify the whole deployment, we're going to to split up all the deployments into layers. So there will be an OpenStack layer that is already for the existing OpenStack, Juju OpenStack controller layer, a Kubernetes layer, a Juju Kubernetes controller layer, and an OSM layer. And as most of you already know, after the Hackfest, controllers, Juju controllers are in charge of being deployed on top of the cloud and enables Juju to deploy afterwards models and charms. So in this demo, I'm going to show off 2 terminal screens. On this side, for you it's the right side. I will show the Juju status of how everything is going to be deployed, and on the other side I will just show the log of the simple command that we're going to be executing, with which it will deploy the whole workload. So this is going to be the simple command, fc build, and with this everything will be executed. So the first thing that is going to be executed and deployed is the OpenStack controller. You will see that Juju currently has nothing deployed. It will deploy the OpenStack controller and create a model, so it's ready to deploy Charmed Kubernetes. So after deploying the OpenStack controller, it would deploy the Charmed Kubernetes. This would also, if you can see, the applications are created. Yes. Okay, so you can see that machines are assigned inside of OpenStack for all the units that the applications used. So if you notice, the Kubernetes worker has a scale 2, so it will have 2 machines because there are 2 units. So, that allows us, the flexibility of Juju allows us to scale our applications after being deployed and configure them with a lot of ease. And everything is just done with Juju. So this will be deploying, and the end result would be fully deployed Kubernetes that could be scaled at any time.
So just to be clear that everyone understands, so in most of the cases for our commercial deployments, our customers would use NVI environments, so OpenStack environments to deploy their workloads onto. We've consciously decided that it would be a valuable tool if we deploy the NVI environment to actually, in the tenant space of OpenStack, actually create a Kubernetes cluster and deploy OSM there. Obviously that OSM placement or Kubernetes cluster placement could be elsewhere on bare metal if you don't want it in the OpenStack tenant space of your NVI environment. Alternatively, we could also use the modeling capability and the layering concepts shown in this internal deployment tool to go and place the Kubernetes cluster on the I would say tooling layer of your NVI environment, where a Kubernetes cluster would then run all of the tooling, including the LMA stack, the metal automation, the Juju controllers, and the OSM components. This is obviously a choice. So we don't dictate to customers where the placement happens, but we do allow for the flexible placement of these models.
So once the Kubernetes is deployed, the next step would be to bootstrap the Juju Kubernetes controller. Press back again, right? Yeah. So that step is to enable Juju to deploy Kubernetes charms on top of our Kubernetes, and once we have that, we will deploy our Charmed OSM. So you can also see it's creating applications, and it will assign containers for pods for each application, and this allows us to really simplify the process and also give it a lot of configurability and a lot of personalization, like Arno said, so it's really customizable. This is also scalable, of course. Each application can be scaled, so there can be several units for each application, and that will be the end result. And yeah, so this enables us, this internal tooling of Canonical really enables us to have a lot of flexibility and also integrate Charmed OSM inside of our already existing products that are Charmed OpenStack, Charmed Kubernetes, and yeah, everything with Juju.
Okay, now in this section we're going to show off the Charmed distribution of OSM in HA. This distro is already being deployed on top of a CDK or Charmed Kubernetes that is deployed on AWS. And we are also going to show how we do and manage all the security updates using the Kubernetes channels.
So what I wanted to add was the reason why we chose a public cloud deployment target in this case was that a lot of customers have their doubts, right? We work with big customers and some sections of that customer might understand the capabilities within OSM, but we do still see customers doubting whether OSM is capable enough to go into production and capable enough to do something complex like developing network slices for 5G or custom service placement, right? So what we chose consciously to do is, in most big telco operators that we work with globally, those customers would have really strict security policies in place. They wouldn't be able to make test environments really easily accessible, remote access to those environments, setting up security rules. There's a lot of complication to get them to the point where they can play with OSM. So what we consciously chose to do in this case was we allow, because it's a Kubernetes-based deployment, any of the big public clouds can be used as a target environment for the deployment of OSM, which would then give them immediate access to OSM to start playing, to start placing workloads, to start developing network services. And they could still, from that AWS instance, for instance in this case, target a Vim API endpoint within their network, right? An existing lab somewhere, which would be an easier process to set up, that one security port, and setting up all the ports of getting this deployed.
So, and also it's important to mention that we spin our own Docker images, as we said in the previous session in the developer stack. And yeah, so we, to not lose more time, we are going to show a bit of the demo.
Yeah, so as you said, I'll maybe tell you a little bit more about the Docker, spinning our own Docker images. The reason why we do this is most production customers would in real time face issues or require bug fixes or face issues where you would need to see the ePatch package to make sure that it's not vulnerable, right? So in the case of Canonical, we already host multiple types of complex software as Docker images on our own Docker repository. And we make this internally available for all deployment tool sets and automation frameworks so that it can pull from those repos, right? So in the case of OSM, we take full upstream. We enable the Dockers to be spun after being patched, CVE patched, and then we make that available and we host that highly available environment so that it is always available to any distribution being deployed at customer.
Yeah, okay. So now we are here in the terminal and we can do a user status. Let's see if we can see everything. Okay. So, here we can see all the components, the same as we saw in the previous session. But here we can appreciate that every application has 3 units of each. So we have 3 Grafana's, 3 Kafka's, 3 units per application. Okay. Also, we are able to do kubectl get pods to see that everything is running on Kubernetes, and there are 3 pods per application too. So it's, well, we can see the same thing in the user status and in the kubectl, but the user status shows it more in a more user-friendly way. We have deployed some network services, and as we can see here in the logs, there is one service that is in a failed state. Okay, that's well, we are going to show it on the UI to see it better. Okay, so one of the network services is okay, and the other one is not okay. That's a bug we found on Arrow. And it happens when the arrow is escaped and we added it. And then when we are trying to deploy network services, depending on which unit of the arrow is contacted to, and this failure happens or not. So the error is basically that the arrow that manages this network service didn't found the data center to deploy the network service. I don't know if you go to the slide. So we are going to show now how could we easily upgrade our RO with a new Docker image that we have spin with a custom tag in our registry. So we are going to now.
So this is a full production environment running workloads already. We've tried to deploy a network service. We found the bug in RO. It's one of the containers that we control and host. So we will now patch that RO, spin a new container, and make it available to all the distributions for all customers, so that they are enabled to go and fix their current deployed solution.
Have the link here. Okay, the arrow is the one that seems a bit different in the status message. So we are going to execute the UU upgrade charm, the arrow. We specify the channel and we update the resource to the image that has the HA patch, let's say. So we do that. Okay. Add to the model. We can do a UU status now and see. Well, here we can see that the charm is being upgraded. So the upgrade charm hook of the arrow charm is being executed, and now all the pods on Kubernetes are going to take this new image that we push to our registry with the patch, and we shouldn't get any errors. Okay. Also, the message has been changed, so it's taking now. It's using the new charm version with the new Docker image. So now we could just create several network services. Oh, sorry. Okay. So can create 2 or 3. For this presentation, I'm deploying these network services in the same AWS in which this OSM is being deployed.
You use the same name all 3 times?
Yeah, it doesn't happen. It doesn't matter. No. The ID will be different. Okay, so now, well, one of them, remember there was one with the error, one successfully deployed, and now I have deployed 3 of them more. So I leave it in the same state. Okay, so now I'm going to execute again the command, and we can see that all 3 new instances are using the correct Docker image with the patch and everything. So.
Yeah, so I mean, it's just one small example of how if you sorry. So it's just one small example of how in the field you could face actual issues when deploying a number of things, and then the ability to actually patch your distribution without redeploying, without needing to upgrade it in a heavy process or with really difficult and complex tools becomes extremely important to save on the operational expense for maintaining that distribution. So for us it's important to remove that friction and enable customers to move fast, because a lot of our customers are the more advanced telcos that want to do really interesting things in whatever the buzzword is of the day. So everyone talks about 5G, everyone talks about slicing, everyone wants to do something interesting, right? So who are we to hold them back? And we would like to help them move forward. Thank you very much.